In this video, we are going to do 16.04 count. Alright, so I have the file opened up in Racket, so let's just look for the problem statement here. Design the function count that consumes a list and a value. The function computes the number of times that given value appears in the list. So they give us an example here, so notice that this function consumes two arguments. This is the first one, and this is the second one, alright? So count this list of 997, count up the nines, right? And that should produce the number 2, right? There are two 9s in this list. All right. So count 997, the list, right? But count up the number of 7s instead. And that should produce the number 1. Okay. So here is the signature, the yields signature, and the purpose statement. So pause the video and try to work through all the other steps on your own. I'm going for spoilers in 3, 2, and 1. Alright, I'm assuming that you guys took a good swing at it, so now let's go over it together. So we're going to stub this out. Signature, purpose, this is the stub, so count, and we're consuming a list of any as the first argument, so I'll just call it the any list as the name of it, and we're consuming another any, so let's just call that val. Alright, and this has to produce a number at the end of the day, so let's just do 0 as a dummy to run against some tests here. Alright, so count empty 2, right? Are there any 2s in this list? No, that's an empty list, right? So we should produce the number 0. Let's do another example. So count cons, let's say, I don't know, 6, empty, and then 6, right? Count up the number 6s in this list. There's only 1, so this should produce the number 1, okay? And likewise, if we pass it, give me the number 4 in this list. Well, this list only has the number 6, so this should produce 0, like so. Alright, let's do a 2-element long list. Count will just give us the cons 9 and cons 9 empty, right? Count out the number of 9s in this list, right? Well, there are 2 9s in this list, so this should produce the number 2. And likewise, you can copy these examples up here, right? This is a 3 long list. So check expect. This should give us also, there are also 2 9s, right? This one is a 3 long list with a 7 now. And here is counting up to 7 in the list. So check expect. Count the 7s in this list. There's only 1 7. All right, so this should produce 1. All right, so let's run against our stub here. Just mismatches. We are fine. Comment this out and grab the template above. Okay. Rename it to count. Make sure it follows the signature, so it consumes a list of any, so that's the first argument. Then we have to give it another argument called val. Alright, so like so. Alright, so now really pause the video. Hopefully this should be all the mental scaffolding needed to solve for count. And I'm gonna go over spoilers in 3, 2, and 1. Alright, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at our examples here, right? So cons empty 2, right? If we look for 2 and we're given an empty list, right, we should produce 0. So that kind of indicates that our base case should be 0, right? If we're given an empty list, we just produce 0. And it doesn't really matter what this value is because, if you're looking for a number in the empty list, the list is empty. There are no numbers. All right, so produce 0. Now comes the harder part, the combinator, right? So sometimes we want to include the count of numbers. So in this list here, right, there's a 9, and then the 7. So we don't want to include the 7. We don't want to count up the 7, right? And same in this case, right? There's a 9, and 7, but we only want to count up the 7. So these 2 9s shouldn't contribute to the answer here, right? The count up of how many numbers that we give it. What number is in the list, right? All right, so... And sometimes we do, right? So it's sort of like 2 paths. And if there are 2 paths, well, we kind of need an if here, right? So that would be the combinator. All right. So if what? If the given value, right? So let's focus on this, one long test, right? All right, cons 6 empty, right? If 6, right, we're given the number 6, I want to look for the number 6 in this list of cons 6 empty, right? How do we do that? We have to compare the number that we're given. So we need to type in val here, right? That's the number that we're given. In this case, right, count cons 6 empty of 4, right? The val would be 4 and 6, depending on, what we call it with, right? So we need to compare val with the first argument, the first value of every list, right? The first of every list relative to every list when you do the recursive call, right? But don't think too much about that. Just focus on the one long list, right? This. So compare 6 with the number that we're given. So we can just do equal, right? All right, so if it's equal, what do we want to do? Well, we want to count them up, right? Because there's 1 6 here, right? So we're going to add 6. What do we want to add 6 onto? Well, we got to still look through the rest of the list, right? Because these are 1 long list cases. But for lists that are 2 long or 3 long or 4, 10, 20, etc., right? We still got to keep looking through the rest of the list. Therefore, we have to continue with a recursive call to itself, right? So we're going to rename this template call here count, right? And we're going to call it with the rest of the list. Also, remember that count takes 2 arguments, right? 1, 2, right? So we have to reflect this here, right? Val is auxiliary data that comes along for the ride, like so. Okay, so if it's equal to the number, we want to add it, we want to count it up, right? So let's say this one, 7, right? Is 7 equal to 9? No, right? So it's going to take this branch, actually. So what do we do in the false branch, right? What do we want to do in the false branch? Well, we want to continue looking through the rest of the list, right? Because there might be a 7. We're looking for a 7 in this list, right? And we might eventually go over it, so we have to keep going through the list. And so we have to do the recursive call here and assume that it will work for the rest of the list. Also passing in val here because count consumes 2 arguments. All right. So 9, does 9 equal 7? No. Does 7 equal 7? Yes, it does. And we're going to add 1 to the rest of the list, right? In this case, the next iteration would produce empty, and we should produce this one. Anywho, let's just run this code. And it works. All 6 tests do pass. And you are free to pause the video, right? Comment out some tests and focus on just 1 test of any length long, and it'll work. All right. I also write things down in a table method for a bird's eye view. But nonetheless, let's just submit this into Handin, and I recommend you check your score on the website and make sure it passes the grader tests. All right. And that is about it for this video, and I will catch you in the next one.